We had a question about this one. This is from, I believe, the practice quiz. And so you're given this circuit, and the problem wants to know what happens to the brightness of the bulbs once you throw this switch over here. And so let's just call our battery to be a 12-volt battery, just because that's nice and pleasant to me. And I'm going to claim that for this one, I like to use this power equation for brightness. So the original person that asked about this was asking about a light bulb 3. So light bulb 3, if you look here, light bulb 3 is in parallel with the battery. I go from the top of light bulb 3 to the top of the battery, and the same thing down here. Now, since this is an ideal battery, which that's really important, right? If you're wondering what can happen, look at multiple choice number 4 from the 2019 quiz 3 for looking into a non-ideal battery. But if it's an ideal battery, then it's going to deliver the 12 volts this guy no matter what's happening over here. And so I know that power is V squared over R. The R stays the same, the V stays the same, the brightness of 3 stays the same. Now we look over here. Before I throw the switch, the circuit looks kind of like this here. And so let's just kind of relabel these as resistors just to be a little bit more clear. So that's R1, R4, that's R3. Okay, and so now what happens is if I look here, these are identical resistors, right? They're identical light bulbs. So what happens is these guys should both have a voltage drop of 6 volts. So R1 and R4 should have a voltage drop of 6 volts. So this is the voltage drop initial, if you will. And so let's think about the voltage drop final. So those are both 6 volts. And that's because they're the same resistance, and so there's going to be some current coming along here. And what's our voltage drop? Our voltage drop is current times R. And so the thing is, in both of these cases, it'll be current times R. And so we don't know exactly what that current is, but since it's the same R, and we know it has to be the same current, it has to be equal, and so we can just surmise that it's 6 volts. Now, let's look what happens in the next case. So in the next case, so we'll get rid of this stuff too. So we put this other piece in here. In parallel, this is the R2. These are all identical. And so now what's going to happen is we can combine R1 and R2. That's one way to think about it. All right, so R1 and R2, and I'll call this R12. Now R12 is going to have a resistance of R divided by 2. If we call the resistance of all these light bulbs R. And this one is going to be R. So right here, we can just sort of say that, okay, so again, I know my delta V equals I times R. Well, just whatever the current is, we don't even know what it is. It's going to come through here. It's the same current times R divided by 2 and the same current times R. And so we know that the voltage across both R1 and R2 has to be less than the voltage across 4. Okay, and so what does that mean? Well, we don't, so what that means is the R1 voltage has to decrease, which means it gets dimmer. The R voltage, R4, has to increase, which means it gets brighter. And so there you have the answer for those two. And of course, R2 gets brighter because it was completely dim before. Again, lots of ways to think about this. You don't have to think about it this way, but just trying to give you a method here. And again, for me, this one was much easier to use V squared over R. Thanks.